I now want to talk about the idea of using determinants and cofactors to find the inverse. So this is an alternative method for calculating the inverse of larger matrices. It looks something like this. So we denote the matrix of cofactors by C, and we just progressively take these cofactors for each position. Then we can calculate the inverse by doing 1 over the determinant of A times C transpose. So we need to be able to find our matrix of cofactors, transpose it, and then multiply by 1 over the determinant. Let's look at an example of this. Here's the matrix I want to find the inverse for, and I'm going to start by finding this cofactor matrix. So as we find cofactors, we want the first one, so we're going to delete the first row and first column, and then we take the determinant of what's left. 2, 1, 3, and 4. We're now looking at the first row, second column, so we delete that, and once again take the determinant. 0, 1, 2, 4. We're now still in the first row, but the third column, so we'll take this determinant. 0, 2, 2, 3. And now we can move down to the second row. So we're on the second row and the first column, so we get rid of the second row and the first column, taking the determinant of what's left, 6, 7, 3, 4. Now we're in the second row, second column, so we'll get rid of those. We're left with 3, 7, 2, 4. We're still in the second row, but this time we're in the third column, so we'll get rid of those. We're left with 3, 6, 2, 3. We're now moving down to the third row. Third row, first column, has our determinant of 6, 7, 2, 1. Still in the third row, we'll look at the second column. That gives us 3, 7, 0, 1. Finally, third row, third column, we're left with 3, 6, 0, 2. Now that we have those, we have to remember the cofactor also had a -1 to the I plus j term. And that was our checkerboard pattern. This first one's positive, this is negative, positive, negative, positive, negative, positive, negative, and positive. So we do have to account for that as well. And now that I have that, I can start simplifying this matrix here. The first term, 2 times 4 is 8, minus 3 is 5. The second one, I have 0 minus 2 to get -2, and then we have another negative sign, so that makes it +2. Here I have 0 minus 4, that's -4. Moving to my second row, 6 times 4 is 24, minus 21 is 3, and we have this negative sign, so -3. This is 12 minus 14, that's -2. 9 minus 12 is -3, and we have this another negative sign, so +3. This is 6 minus 14, that's -8. 3 times 1 is 3, minus 0, so 3, and then we have the negative sign, so -3. And then 6 minus 0 gives 6. So now we have C. To actually find the inverse, we need C transpose. So we'll switch the rows and columns. The first column is 5, 2, minus 4. Second column, -3, -2, 3. Third column, -8, -3, 6. So this is a good start. We're not quite done. We need to divide this by the determinant. So I'm going to write down the original matrix again. 3, 6, 7, 0, 2, 1, 2, 3, 4. And we need to take its determinant. I'm going to go down the first column here since it has a 0. So I have 3 times. We delete the first column in the first row. I'm left with 2, 1, 3, 4. We then have a 0, so that one doesn't matter, plus 2. times deleting that row and that column gives us 6, 7, 2, 1. This simplifies to 3 times. This is 8 minus 3 is 5. Plus 2 times 6 minus 14 is negative 8. So we have 15 minus 16 is negative 1. So we need to multiply C transpose by 1 over this determinant. And that will give us our inverse. So we get a minus 5, 3, 8, minus 2, 2, 3, 4, minus 3, minus 6. And we could absolutely use row reduction here to actually make sure this works. And this is what we should get as the inverse.